Good morning, everyone. Hope you're having a wonderful day today. Well, I forgot to turn on the screen share, so now I have to do this again. Yay. Okay, so we're going to go over section 3.3, dividing polynomials, remainders, and factors theorem. So before we do dividing polynomial, let me go over how to do long division. So here we go. Let's start with a 374 divided by 3. So the process is we take 3 and see how many times it goes into the first number. So 3 going to 3 one time, so we write the number on top. And then we subtract, so 1 times 3 is 3. We subtract 3 minus 3 is 0. Then go bring down the next number, 7. 3 going to 7 how many times? 2 times, so we take 2 times 3 is 6, so 7 minus 6 is 1. Bring down the next number. 3 going to 14 4 times, that's 12, so 14 minus 4 is 2. So each one of these numbers have a name. So this one is called a dividend. This is called quotient. This is our divisor, and this is our remainder. So what do we have when we finish dividing? So if I take 374 divided by 3, then I get 124 and 2/3. Well, if I take this 3 and I multiply it to the other side, then I can say that the dividend is equals to the divisor multiplied by the quotient plus the remainder over the divisor. So make sure that you are aware of this right here, because we will use it later on. So let's look at the process on how do we divide long division. Well, before we do that, make sure that you take the note that each exponent represents a digit. So therefore, we need a placeholder. As you can see here, we have the x cubed and the constant term missing. So when you want to think about it, the constant is in the 1 place, the x is in the 10 place, the x squared is in the 100 place, and so forth. So since we're missing the x cubed, okay, we need to use 0 as our placeholder, and we need to use 0 as a placeholder here for the constant term. So anytime that you are writing an expression, make sure that every single exponent is present. So here we have x to the 4th, x cubed, x squared, x to the 1, and the constant. So now let's go to divide. So make sure you write out all of them. Okay, this is very similar to the long division. So let me erase all this and we'll start over here. Okay, so anytime that you divide, make sure that you stay within the correct column. Okay, so here you have x fourth, x cubed, x squared, x, and the constant. Okay, if you don't have a coefficient, it's understood to be 1. Same thing with the exponent. So we're going to do the same thing. This time we only look for the first term here of our divisor. So first ask yourself, x times what give you x fourth? So here I already have 1x. I need 3 more, so it'll be x cubed. So you need to line up your x cubed over in this column because that's where x cubed go. And let's look at the coefficient. 1 times what give you 4? So that's 4. So now we have our quotient. So we take our quotient, we're going to multiply it with our divisor. So we take 4x cubed, multiply with our divisor. Now we need to distribute because there's 2 divisor this time, that there's 2 terms here in the divisor. So we have 4x cubed minus 16x, I'm sorry, 4th. And then we're going to subtract. Now, don't just write the subtraction sign here. Make sure that you put parentheses around it. Okay. Now, the reason why we put parentheses because there's 2 terms in here. We need to distribute that. So I can switch all my signs. Okay. So 4x to the 4th plus a negative 4x to the 4th is 0. Now, if this number here is not 0, you did something wrong. So this here is always have to be 0. Okay. because we're trying to reduce the exponent one by one. All right, 0x cubed plus 16x cubed is positive 16x cubed. Now we're going to bring down our next number. Okay, so now we're going to start all over again. So here, x times what give me 16x cubed. So I know I need to have an x squared here. 1 times what give you 16? That's a positive 16. And then we're going to take our divisor. I'm sorry, we're going to take our quotient, multiply with our divisor. The same process. Distribute. So we have 16x cubed minus 64x squared. We're going to subtract. And don't forget to switch all the sign. And then you just add straight down. So that's 0. This here is 61x squared. Bring down the next number. And start the process again. Okay, x times what give you x squared? So I need a positive x. And I also need a positive 61. Same thing. We're going to multiply. And we're going to subtract. Make sure you change out all your signs. All right, so we have 249x here. Bring down the next number. So almost done. All right, so x times what give you 249x? So I need 249. So 249x minus, let's see, what is 249 times 4? Gives you 996. Don't forget to subtract. So we change our signs. So 0 here and positive 996. Okay, so we have a remainder of 996, and this is our quotient. So in order to write out our final answer, we have 4x cubed plus 16x squared plus 61x plus 249 plus 996 divided by x minus 4. So there is our final answer. Okay, let's try this another example over here. Okay, so let's check to see if all our digits are present. So we have x squared, x and constant. So that's good. We have x and constant. So that's good. Okay, so we start with our first term of our divisor. 5x times what give you 15x squared? So 5 times 3 is 15. X times x is x squared. So I need a 3x. So I line it up here in the x column. Then I'm going to take the 3x, multiply with my divisor. Make sure you distribute. And then we need to subtract, which means we need to change out all our signs. So this becomes plus, minus, plus. So this is a 0, so that's good. 19 plus 6 is 25. Bring down the next number. All right, 5x times what give you 25x? So I need a 5, a positive 5. Go ahead and distribute. Make sure you change out all your sign. And we have a remainder of positive 8. All right, so our final answer is 3x plus 5 plus 8 over 5x minus 2. All right, so the next one, let's make sure that all our terms are present. X cubed, x squared, x constant, so that's good. X and constant, that's good. Okay, x times what give you x cubed? So I need an x squared. Multiply again. Change your sign. And then repeat the same process. So this time I need a negative 2x. Okay, change all the sign. This one I need a 2. So we have 2x minus 2. If I subtract, I put both of them to be 0. So here the remainder is 0. So that's great. So that means that my answer is just the quotient here. No remainder. So that actually tells us something if the remainder is 0. Okay. So I'll tell you this now, but we're going to go over it formally later on. So if the remainder is 0, then the divisor is a factor of f of x. Okay, so if you see up here, this is what I mean. So if I have x cubed minus 3x squared plus 4x minus 2, and I was able to divide by x minus 1, and my answer was x squared minus 2x plus 2. Now, of course, another way we can rewrite this is this. I can move this x minus 1 to the other side, so you can see that these two are actually factors. So the divisor is the factor, and the quotient is the factor of this dividend. Okay, so you can see here that if my remainder is 0, I have nothing over here to add. So therefore, I can just multiply these two. So these two, when you can multiply them, they are called factors. Okay, so this is actually a something called a factors theorem. So we'll go over that more details. All right, so here is our division algorithm. So I show you at the beginning. So if f and d are polynomials with d not equal to 0, so here that's our divisor. So if I take f of x, which is our original function, I take my divisor times my quotient plus my remainder. So that's just how regular numbers work. And it's the same thing here for polynomials. And so the last part here, the remainder Rx, if it equals to 0, then it's said that the divisor and the quotient are factors of the dividend. So this is what I explained to you earlier here. So these two are factors of f of x, and f of x here is our dividend. Okay, so now I'm going to show you a quick way of doing long division, and that is called synthetic division. Now, we can only do this if our divisor is in the form of x minus c. Okay, so let's go over it over here. Okay, so synthetic division is a quick way of doing something, of doing long division, but you can only use it if the divisor is in the form of x minus c. So let's look at this example here. We have 9x squared minus 4x minus 6 divided by x minus 5. So this here is our divisor, and it is indeed in the form of x minus c. So c here is equals to 5, okay? All right, so in order to do this, we only use the coefficient of our dividend. Okay, so make sure all terms are present. Okay, so that means that make sure all the digits, like I mentioned earlier, here we have 9x squared, x, and constant. So all the terms are present. So let's say I'm missing an x here, you would use a 0 as your placeholder. So make sure that you do that, or else long division, synthetic division will not work. All right, first I'm going to use coefficient. So I'm just going to write out the coefficient instead of the entire thing. So 9, -4, -6. Okay. So as a reminder, though, I'm going to write the exponent up here just so you can remember to write them all out. And over here, I need my c value. So this is one of those reasons where you cannot use anything that's higher than to the first power. So here x is to the first power. So if it's x squared here, you cannot do this. So c here is 5. So see if you can rewrite the divisor in the form of x minus c, so you can see what your c value is equal to. Now, if, for example, I have x plus 5, so that means that this is x minus -5, so your c value here would be -5, okay? So an easy way to remember is it's always going to be the opposite of what this is. Okay, so if this is -5, you use 5. If this is +5, you use -5. Okay, so here is the process. I'll use a different marker here. So first step, we're going to drop down the first number. And then we're going to multiply the c value with the number on the bottom. And then we're going to put the result to the next space to the right below the to the adjacent column. So 5 times 9, and then we're going to add them straight down. So here I get 41. Next, we'll do the same process over again. So now I'll take 5 times 41, put the answers over here. So that's 205. And then add straight down. Okay, so I have 199. All right, so after we finish, now we are out numbers, so we finish here. So what does all these numbers here mean? Well, here's the reason why I put these up here, is that after you finish, the degree of each of these number down here will be 1 less than what you wrote up here. So here you start out with an x squared, so that means that this 9 here is going to be an x. Here you started with an x, now you're going to have a constant. Here you have a constant, this is going to be our remainder. So the last number here is always going to be the remainder. Okay, so our answer is 9x plus 41 plus 199. And remember, we put the remainder over the divisor. The divisor is x minus 5. And this would be our solution. So let's go back into the 3 previous examples and see if we can use synthetic division on any of them. All right, can we use it on this one right here, the first problem? You can see here that this is fairly complicated because it looks kind of tedious and long, right? So here we see that it is indeed the divisor is indeed in the form of x minus c. So we can use synthetic division on this one. So let's do this problem again and see if we have the same solution, and we can compare and see how much faster it is. So again, make sure that you have all of your digits present. So here we have 4. I don't have an x cube, so I need to use a placeholder. And my c here would be 4. Okay, so again, I'm going to write it up here just so we remember that all of our terms are present. All right, so now drop down the first number and multiply. So 4 times 4 is 16. We're going to add. 4 times 16 is 64. We're going to add. We'll multiply 4 times 61. 2 and 44. We're going to add 249. And I believe that one was, let's see, 996. And add straight down. All right, so this one would be our remainder. Now let's get, so all of these numbers here are coefficient of the answers, okay? And the variable is 1 less than the degree here. So this start out x fourth, this becomes x cubed. This is x cubed, this becomes x squared that becomes x becomes constant. So this is all positive, so put plus between them. And our answer for x cubed plus 16x squared plus 61x plus 249. And this is our remainder, 996 divided by the divisor. So you can see here, this is much, much faster and much easier than what we did over here. So we can see we got the same answer. Okay, but doing it much quicker and less likely to make a mistake. Okay, let's do these two. All right, let's see if our divisor is in the form of x minus c. So you can see here, x plus 1. So this is the same thing as x minus a negative 1. So my c value is negative 1. All right, let's make sure that we write this. And we are missing an x squared term here, so we need to add in a 0x squared. So we have x cubed, x squared, x, and constant. So let's write down the coefficient for those. Oops. See, notice I have a mistake because there's an x squared right here. All right, bring down the first number, and we're just going to multiply, put the answers up here. Add straight down, and do the same process again. And you're done. Very quick. All right, so we're going to reduce 1 degree to get x squared, x, and this is constant. So we have 3x squared minus 3x minus 3 plus 7 over x plus 1. Okay. All right, so this looks pretty long. And I would hate to do this using the long division. So good thing we have synthetic division. So 1, negative 1, 1, negative 2, 3, and negative 6. So make sure you get the signs in front of the numbers to go with it. All right, my c here is negative 1. Same thing. All right, here we go. So our answer here is x to the fourth minus 2x cubed plus 3x squared minus 5x plus 8 minus 14 divided by x plus 1. All right, let's look at the remainders theorem. If the polynomial f of x is divided by x minus c, then the remainder is f of c. Well, what does that mean? So let's look at this one here. So up here, that's my f of x, okay? And it's dividing by x minus c. What is my c value here? My c is -1. Then the remainder, so the remainder here is -14. Then the remainder is f of c. So what does that mean? So if I take f of x, and I'm going to put c in there, so c here is -1, and my remainder is -14. So basically that just means that this value here is your x, this value here is your y. So your c is x, and your corresponding y value to that is your y. Okay? So let's prove this. So if I take f of -1, I'm going to plug it into my function here. -1 to the fifth minus -1 to the fourth plus -1 to the third minus 2 -1 square plus 3 -1 minus 6. And we know that this is going to be equals to -14, but let's check. All right, so we have a -1 here, -1, -1, so that's -1, 2, 3, 4, 5, 6, 7, 8, 8, and -6 is -14. Okay? So here, this is a c value, this is the remainder. Okay, so use synthetic division and the remainders theorem to find out the indicated function value. So all you have to do is use the remainders theorem to check to see what this is. So this is my c value, and let's see what the remainder of this is after synthetic division. All right, so notice we don't have an x term here, so make sure you remember to put in your placeholder. All right, so it looks like my remainder here is 0. So f of -1 is equals to 0. But what does this 0 here mean? If I were to plot this on a graph, it is say -1 and 0 is right here. Well, if I have a graph and it crosses to this point is the x-intercept, or also called 0. So this kind of reminds you of what I said earlier, is that if the remainder is 0, that means that this c is a 0 or an x-intercept. So that's very important. Same thing here. I'll give you a minute to try it, and then I'll show you the answer. Okay, so after this synthetic division, my remainder was 17. So f of 4 is 17. I did this a little bit extra. You don't have to do that. Oh yeah, the factors theorem. All right, so if f of x is a polynomial, if f of c is equal to 0, so what does that mean here? So that's the same thing as we did earlier in this problem right here. This is f of c. With f of c is equal to 0, so our remainder here was 0. So if that happens, then x minus c is a factor of f of x, and vice versa. So if x minus c is a factor, then f of c is equal to 0. Well, that's the definition of a 0, right? So if the y value is 0, then that means that x is a 0. So we want to solve for this equation given that negative 1/2 is a 0. Now, that's important. So if this here is a 0, then that means that our remainder is equal to 0. Okay? So what we can do here is we can reduce this f of x down to x squared, so we can solve for it by using quadratic formula or by factoring. So here is the process. We're going to use this f of x. We're going to use synthetic division on this c right here, and we're going to reduce it down by 1 degree. So let's do that. All right, so set it up just the same as we did before using synthetic division. So here I'm bringing down my first number, multiply, so this is negative 6. Combine this, you get negative 5. Multiply this to get 5/2. And add this, you get negative 4 over 2, which is negative 2. Multiply this, you get positive 1, and the remainder is 0. If your remainder is not 0, you did something wrong because it told you that negative 1/2 is a 0. So therefore, you must have a remainder of 0. So let's rewrite this here. So I have 12x squared minus 5x minus 2. So now I need to solve for this equation, right? So I need to find 2 more zeros. But you know how to solve for this. This is just a quadratic. You can try to factor it. You can try to use synthetic division again. Or you can just use the quadratic formula. Well, let's see if this thing will factor. So this is my method to factor. Is use the cross method. So this first column right here, I'm going to find factors of a. A here is 12. So there's many choices. I can use 1 and 12. I can use 2 and 6, 3 and 4. So I have these choices here. I'm going to choose 3 and 4 first. So over here, this column right here are factors of c. So I only have one choice for that. So I can use 1 and negative 2, okay? Or you can switch it around. So let's see. I'm going to use, let's see, 2 here and 1 here. And the hint here is that the larger factor of c gets signs of b. So here's b right here. So the larger factor of c here is 2. So that is going to get the sign of b. And since the sign of b is negative, this is going to be a negative. Now, this will work 90% of the time. It will work all the time, okay? But most of the time. So in order to check to see if this is the correct factor, let's multiply across this line here. All right, so I have 4 times negative 2, that equals to negative 8. 3 times 1, that equals to 3. And I'm going to add these together, and if this is equals to b, then it is correct. So negative 8 plus 3 is -5. So that is the correct factor. So if you don't get the correct factors here, you can switch the order of these two. You can switch to different numbers or factors of A. You can swap these two. So you can do all kinds of things to try to get B. Okay. All right. So in order to write our factors, we're going to read it straight across like this. Now here I left out an x because I need to get an x squared, so I need to add an x to each one of these. So my final factors is 3x minus 2, 4x plus 1. And that is a factor of this function. So now I can set each one of them equals to 0 and solve. So here x is equals to 2/3 and x is -1/4. So here I have three solutions, and then the first one here is -1/2. So x equals to -1/2, 2/3, -1/4. And that is my final solution to this equation. Okay, so here we are given a graph, and it asks us to use synthetic division to verify that this number is a solution of the equation. So this here looks like -1/2, this looks like 1, this looks like 2. So let's verify those numbers. So these are our potential 0. So that means that if I use synthetic division, my remainder will equals to 0. Let's do that. I'm going to choose 1 first because that's probably the easiest one to do. It does not matter the order that you do them in, okay? So you choose any numbers out of these three. All right, so that's good. So that means that we finished the first one because our remainder is 0. So we check off that one. So 1 is a 0. And now we do the same process again. This time, this is x squared now. So this is 2, -3, -2. So we use the same value here. Okay, so you don't have to use the original ones. You can just use the ones that you are left over. So again, oh, I'm sorry, not 1 here. Let's move to the next one. Let's go 2. Okay, add straight down. And again, this is 0. So that works. So now what we have left over. So this is x squared. So that means I'm going to have an x here. This is x. So this is going to become constants because we reduced it by 1. So now this is what's left over. So I can set this equals to 0. And you can see that this is -1/2. So we've confirmed all three of them are indeed zeros. Okay. All right, please let me know if you have any trouble with this. It's going to get much harder in section 3.4 because each problem is going to be very long. And we're going to put together everything here that we've learned in order to solve for the equation. So let's look at what to expect next time. So you see this problem right here, they tell us that one of the 0 is -1/2. Well, how do we know that? Okay. Well, in the next section, we're going to be able to test a bunch of different numbers to see if one of them will work. So in the next one, all they're going to give you is this equation and ask you to solve it. They're not going to tell you that one of them is a 0. So we have to find all of it by ourselves. We're going to review all of the methods that we learned so far and how to apply it in order to find the zeros. Okay? And then at the end, they're probably going to ask you to graph it as well. Okay? Have a great one. Hope to see you on Wednesday. Bye.